So good afternoon, everybody, and
Hello.
yeah, welcome to class. All right, so I did grades quiz, and I put it, I put the grade on Brightspace. If you go to your grades, you're gonna see it, and then I sent everybody's copy, through Brightspace, probably to your CCBC email, whatever email is in the system, so your copy went there. So, please, when you do that, you have to do a particular effort of giving me a legible copy, because I need to know what is your answer. I need to be able to understand what question are you treating right now. You see, I cannot just figure out some stuff, by myself. So please do that particular effort. Some students, they give me like very nice copies, stuff like that. Some other people, you know, didn't do that effort. You have to do that effort. It's not about, about the handwriting. It's not about that. It's not about having a nice handwriting or not. It's just about being organized. Whatever question you are treating, question number one, you know, write question number one, and then when you're done with it, you give me only one single answer. You don't give me two answers or three answers, just one answer. We always get the one answer for a problem. We can't have like two answers, okay? You go to question number two or number three or number four. When I grade, I have to be able to, to navigate through that. So if I'm not able to do that, then the grading becomes very, very hard. All right. So for those people who missed the quiz, obviously when somebody misses a quiz, they got a zero. Okay. There is nothing we can do about it. Okay. So, and now, is that like the end of the semester? Is not, because, but there's nothing we can do if we do an assignment and somebody just misses the assignment. There's nothing we can do unless it is a particular case, somebody was sick. In that case, they have to have a written objective note, et cetera, et cetera. So uh, uh, we have to do our best to avoid missing the assignments, because a zero will just make the semester harder, okay? It will not make somebody fail because a quiz is 5%, but it just makes things harder. And there's no reason to miss something that was open for almost 2 days, 1 day and a half, you see. There is no reason to miss that, okay? So, and it takes you like 30 minutes to do it, okay? So that is just, if you did miss this one, try to not to miss the other one, try not to miss the test, you know. And one thing that is very, very helpful is when you think you're gonna have a hard time to attend a class, just to establish that communication line, between you and the teacher, okay? Why? Because that helps a lot. Okay, I'm not able to attend this class because of this, because of this, then the teacher knows. And if you have an assignment, you can try to figure out the solution to that. But after the fact, I have to have a written stuff. If I don't have written stuff, we get a zero. Okay. So, all right. So we're gonna continue on. Last time we introduced chapter 2. All right. And the chapter 2 was about functions. But last time we saw how to do some graphs. Obviously, we're going to continue on doing some graphings, later on. And we saw how to find the x-intercept and how to find the y-intercept. We said if you have an equation, whatever it is, in xy variables, if you want to find the x-intercept, you have to set y equal to 0, and then you try to solve for, x. If you want to try to find the y-intercept, you do the other way around, right? Okay, so today we're going to introduce what we call a function. We're going to introduce what is a function, and we're going to go from there. So So that is, our, two. So we don't do 2.2 because 2.2 is out of the program. It is about circles. We don't do that anymore. So 2.3 here is functions, right? The easiest way to introduce a function is through what you call a relation. What is a relation? Is any set of ordered pairs, right? Any set of ordered pairs is a relation. Okay? Any set of ordered pairs is called a relation, you see? So basically, if you have this, 1, 3, 0, -1, we have 2, -1, we have 1, 6, right? And we have, 3, 1, etc. So when you have this is an example of relation, okay? So we have no condition upon that. It's just a set of ordered pairs. You see why we call this an ordered pair? Because, for instance, the first pair 1, 3 is different from the last pair 3, 1. Okay, because the order is very important. Okay, so the first ones are the values of x. The second one are the value of y. Right. So this is, the first numbers are values of x. The second numbers are values of y. So this is an example of a relation. When you have the relation, do you remember what you used to call the domain of that relation?
The range?
The domain of that relation. So for instance, this relation here, this example of relation, what is the domain of this one?
Isn't it the x values?
The x values, right? The domain of the relation is a set of the x values 1, 0, 2. You see, we have 1 again, but we don't need to repeat the 1 and 3, okay? So this is a set of x values. And do you recall what you call the range?
The y values.
The set of the y values, 3, -1, 6, 1, right? So the set of y values. Okay, so for instance, if you do recall, in case you do recall, okay, would we say this relation here, would we say it is a function or not? Do you recall, somebody?
Yes.
Okay, is it a function or not?
The domain?
No, the relation right here, the stuff in black right here. So would you say this is a relation or this is not a relation?
I think it is.
It is a relation. I mean, I'm sorry. Do you say it is a function or not a function? Of course it is a relation, right?
I think it's not a function.
Okay, what would be the reason it's not a function?
I think for functions, there has to be a different x value for each point. And it looks like there are two of the same.
Yes, exactly. So can you point out exactly the example, the two elements that fail this stuff to be a function? Can you point that out to me?
The points 1, 3, and then 1, 6.
Thank you very much, Zainab. You see, these two right here make it not to be a function because we have two different y's for the same x. Okay, every time that happens, this is not a function. Okay, so this stuff right here is not a function. Is not a function, right? Because we have 1x for 2 different y's, right? Okay, so what we call a function here, the definition of it is function so it is a relation where, so we say y is a function of x if for any x in the domain, we have exactly 1 y, right? In the range. If for any x in the domain, there is exactly 1 y in the range. Okay. Oh. So that is a definition of a function. For instance, this example right here, this relation right here is not a function. And what happens when we try to plot this relation? Let's try to plot it, right? I mean, we can plot the points. Let's try to plot the points. So we have like 5 points, right? I think we have 1, 3. Okay, we have 0, -1. We have 2, -1. We have the fourth point is 1, 6. And we have 3, 1. Okay, this is my graph, right? My graph is about 6 points only, or 5 points, okay? So look what happens. You see, what made my function, my graph fail to be a function here, because we said here, right? When x is 1, how many y values we have? We have 2 y values, right? Look what happens here. This vertical line, right? How many times this vertical line meets with the graph? How many times this vertical line meets with the graph?
Once.
Twice, right? Everybody agree with that? This vertical line meets with the graph twice. Every time that happens, we say the graph does not represent a function, okay? This is what you call the vertical line test, okay? The vertical line test is, if you have any graph, that graph would represent a function if no vertical line hits the graph more than 1 time, right? To the most, it's going to hit the graph only 1 time. If it does hit the graph twice or 3 times or 4 times or more, then it is not a function, okay? This is what you call the vertical line test. The vertical line test is no vertical line hits the graph more than once, right? The vertical line test. A graph represents a function if no vertical line meets it more than once. Okay, so for instance here, this is not a function because this particular vertical line meets the graph twice. All right. So, for instance, if I give you this type of graphs, if I give you this type of graphs, I say, you know, this graph right here. What do you think? Is this a graph of a function?
Yes.
Yes.
That's pass the vertical line test, right? Visually, we cannot have a vertical line that's going to hit the graph twice, right? So this is a function. If you have this, all right? So is this the graph of a function or not?
No.
Of course not, right? You see, you can have plenty of examples of vertical lines that hit the graph more than once, right? Actually, you know, the y-axis hits the graph like 3 times, right? So this is not a function, okay? So what type of graph, for instance, what type of graph can never pass the vertical line test? What type of graph? Can you give me an
A
example?
function of y.
Hmm?
A function of y.
A function of y. A function of y can also be a function of x, both, you know. What you call the one-to-one function, okay? It can be a function of x, but you know, that is a good, you know, good thinking. But a function of y can also be a function of x, see? So what else, what type of shape will never pass a vertical line test? For instance,
A circle.
Sideways
a
U.
circle, rectangle, whatever, any closed graph will never pass a vertical line test, right? So they cannot be functions, all right? So that is a vertical line test. Of course, you know, visually it's very easy to find a vertical line test, right? So now, of course, we have lots of ways to represent a function. We can represent a function with a graph, right? Okay. We can represent a function with a table of values, like, you know, in statistics or in, you know, those kind of stuff. We can represent a function with, you know, this type, you know, this representation right here, for instance. You see, this is another representation function right here. All right, we can do this, we can do this, we can do this, okay? But this type of representations are very, very limited. You see, in particular, they apply best when you have a finite domain and a finite range, right? Okay, so we have to find a better ways to represent a function that we don't have to be limited, okay? So for instance, this function is about what? It's about the point, what point? What is the first point? 1 what? The first one is 1, 5, right? The second point is 2, 6, right? And then it is 3, 7, and then it is 4, 8, right? You see? So is this f? I call my assignment f. This is my function f, right? So right here, it is a function, right? So of course, because for every value of x, we have only one value of y, right? So f is a function, right? And we say, for instance, f of 1 is equal to 5, right? You see, that is the notation right here. F of 1, some people think these parentheses are multiplication. They are not. This is not a multiplication, right? This is f of 1, okay? We say the assignment of 1, we assigned 1 to 5, right? Or 5 to 1, okay? With the function f. Is not a multiplication, right? Okay, so how we say that? We say 5 is the image of 1 under f, right? Okay. 5 is the image of 1 under f. Whatever you see between the parentheses is a value of x, right? And whatever you see on the other side is a value of y. So this says f of 1 equal 5. How much is f of 3?
7.
F of 3 is 7, right? And so on. You see? So do we see, for instance, you know, if we had this going 4, 5, 6, 7, 8, 9, 10, etc., etc. So do we see any type of pattern for this assignment? Do you see any pattern here, or is it so random?
Yeah, it's 1/1 my plus 4, correct? 1/1, 1x plus 4.
1x plus 4. We see that we, as if every value of y is a value of x plus 4, right? Everybody see that? That is a pattern here. So we have 1 is assigned to 5 because 1 plus 4 is 5, exactly. 2 assigned to 6 because 2 plus 4 is 6. 3 assigned to 7, 3 plus 7, 3 plus 4 is 7, etc., etc. So if I had an x here, and that I assigned to y here, right? That y has to be what then? That's y has to be?
5.
No, x now is a random stuff, right? X is any variable, so we're going to follow the same pattern. You see, we added 1 to every
plus 4.
X plus 4. Thank you very much. You see, that's why it has to be x plus 4. So I can say f of x is x plus 4, right? That is the algebraic representation of the function. You see, instead of writing all these, you know, enumerating, etc., I can just go ahead, f of x is x plus 4. That is algebraic representation. And this representation will allow us more calculations, right? So to do this representation will allow us to do more calculation. Now we can do a lot of calculation with it, okay? So having the algebraic representation is the best way to be able to do calculations. If you have a graph, you might not be able to do a lot of calculations. If you have a table, you might not be able to do a lot of calculations. But if you have the representation like that, you can do a lot of calculations with it, okay? All right, so from here, we're gonna see how to evaluate a function. And I think this, you know how to do it, right? So for instance, if you say f of x is equal to x squared minus 5x plus 1, right? So if somebody asks you to find f of 3, what you do to find f of 3?
Plug it into the formula.
You plug in 3 into the, for x, right? You plug in 3 for x. You see, that is how we evaluate a function. So whatever is a variable, right? Whatever is a variable, we just go ahead and we plug in that value for the variable x, right? So it's going to be 3 squared, right? 3 squared minus 5 times 3 plus 1, right? You know, if somebody doesn't need to be changed, we don't change it. The plus 1, we don't change it, right? And this is going to be 9 minus 15 plus 1, which is -5, right? Okay, so obviously, these are the easy examples, but the goal is not to be able to do that. The goal is to be able to evaluate the function, whatever it is. So if I ask you, what is f of -2? Go ahead and try to do this. What is f of 0? What is f of x plus 1? All right, go ahead, try to do this. Try to evaluate these. All right, so how much you got for f of negative 2? What answer you got?
15.
15. So when you write negative 2 square like that, right? What is wrong in my writing?
I got 3.
You got 3? Okay, what is wrong in my writing here? When I write negative 2 square like that,
You
what's
could put
wrong
it
in
in
my writing?
parentheses.
Exactly, I'm missing parentheses. So you have to put parentheses, right? You have to. So this is negative 2 all square, and then minus 5 times negative 2, right? Minus 5 times negative 2, and then plus 1, okay? And then it's going to be 4 plus 10 plus 1, which is 15, okay? F of 0, of course, is 0 squared minus 5 times 0 plus 1, which is 1, right? Okay, now f of x plus 1. Can somebody say, tell me what they did first before simplifying? And can somebody tell me what they did?
We have to replace the x by x plus 1.
You have to replace, whenever we see x, we put x plus 1, right? That is correct, Sharif. So you see the x squared right here, instead of x, what I put x plus 1. Okay, I put x plus 1 squared, right? But since it is squared, I don't forget to put parentheses around it, right? Minus 5 times x plus 1, and then plus 1. You see, at least the substitution stage is easy because it is visual, right? The substitution stage. Whenever you ask me to find f of, I replace the variable with what that. I even don't care what it is, right? For instance, right here, just to make my point, if I say f of this, do you know what this symbol means? You see, maybe I even don't know what this symbol means, right? Maybe, okay? But it doesn't matter. Whatever you ask me what is f of, what am I gonna do? What I do is mechanical, right? It is a mechanical, thing. I remove x, what I put in place of x. I put the nabla,
Triangle?
right? Whatever it is, a triangle, right? It's which is a nabla, you know, when we do little physics, you know, you're gonna see this stuff, right? Nabla, you know, in Greeks, okay? So you see, it doesn't matter what stuff is. I just put nabla squared minus 5 nabla, you know, plus 1. You see, even if I don't know what this stuff means, okay? Because what I do is mechanical. I remove x, I put whatever you ask me to put, okay? That's it. Now, if I have to simplify now, okay, now I go ahead and simplify. You see, is this going to be what? It's going to be x squared plus 2x plus 1 minus 5x minus 5 plus 1. So which is x squared minus 3x minus 3, right? So, etc., etc. So this is a case of evaluating. So now if I give another one now, f of x how much is f of 1? How much is f of 0? How much is f of 2? F of negative 5? And f of x plus 1? What do you think?
All of them are 4.
All of them 4? Everybody sees that as the logic of it? Because on the right side, f of x is 4, right? On the right side, do I have any x to substitute?
No.
I don't see no x to substitute. Since I don't see nothing to substitute, that value 4 will be right there, right? Everybody see that? All of them here, it doesn't matter what you ask me. If as long as it is in the domain, f of all of them will be 4, right? How we call this type of functions? Do you know the name? This is A. You see, this stuff never changed, 4, 4, 4, 4. Something that never changed, how can we call it? It is, how can, what, it is constant, right? That is a constant function. A constant function, when you evaluate a constant function, the stuff will never change, right? A constant function, the domain will never change. All right, so right here, I'm gonna give another one right here. So now this one is a little bit more, what you call a piecewise function. You see, this is a function that is defined by pieces. If we say f of x, we attach conditions on the definition, right? You see here, all these functions, we don't have no condition whatsoever, right? It's just f of x equal to x squared. Whatever x you ask me to plug in, I use the same one, the same definition. But this one here is piece by piece. For instance, we say f of x is 3x minus 1 if x is greater than or equal to 2. You see? What are the x's for which I am allowed to use this definition? The only x's I am allowed to use this definition for
X
which
is
I'm
greater
allowed,
than or equal to 2.
they have to be greater than or equal to 2. You see, if you ask me f of 5, do I have right to use this definition? If you ask me f of 5.
Yes.
Yes. If you ask me f of 1, can I use this definition?
No.
No.
I cannot, right? You see? So that is, answer we say negative 4 if x is less than 2. Okay, so for that, so we can ask, for instance, what is f of 4? What is f of 0? What is f of 2? If you ask me what is f of 4, right? Which definition I have to use, the first one or the second one?
The first one.
The first one, right? Everybody agree with that? Again, you know, as we do the class, right? If you feel like you need to ask a question, you have to go ahead and do not hesitate. You know, don't feel bad to stop the class. You know, we are here to answer to questions, okay? If you feel like you don't understand what we're doing, you have to stop me, right? And ask the question. For instance, what is f of 4? We have to use the first definition because 4 is greater than or equal to 2, right? You see? So this is 3 times 4 minus 1, which is 11, right? F of 0 now. Which definition we have to use? The first one or the second one?
Second one.
Second one.
The second one, right? Because 0 is less than 2. So f of 0 will be -4, as we've seen before, right? Now f of 2, okay? F of 2 now. We have to use the first one or the second one?
The first one.
The first one, right? Because 2 is greater than or equal to 2, right? 2 is equal to 2. Because of that, we have to use the first one, which is 3 times 2 minus 1, which is 5, right? We call that a piecewise function, but a piecewise function does not have to have 1 piece or 2 pieces or 3 pieces. It does not. You know, you can have like a lot of pieces. So if we say f of x, all right, go ahead. Try to do this one right here. This is an example of piecewise function.
You want us to solve them, right?
Yeah, find these 4 of them.
Okay.
And then we're gonna see.
Gotcha.
um, All right, so tell me, f of -3, how much you got?
And
You got 10, right? Which one you use? The first one or the second one?
the second one.
Everybody right here, you see, everybody agrees with that. -3 happens to be less than -2, right? So for f of -3, we have to use the first definition, right? So f of -3 is -3 squared plus 1, which is 10, right? Okay, how about f of 1? Which one we have to use? The first one or the second one? For f of 1?
The second one?
The second one, because 1 is greater than -2. So we get -5 times 1 plus 7, which is 2, right? f of -2 itself, which one you have to use? F of -2, you have to use
The second function? I mean, the second condition.
the second definition. Look, -2 happens to be equal to -2, right? Which puts -2 in this category right here, okay? All right, so -2 will be -2 squared plus 1, which is 5, right? And finally, f of 5, of course, we have to use the second definition, which is -5 times 5 plus 7, which is -25 plus 7, which is -18, right? You see, if I ask you, what is f of a? What you have to tell me? Can we find f of a here?
No, because we don't know what it is.
We don't know what is a, right? So we cannot find f of a. You have to tell me further about a. You have to tell me if a is this or a is this. If you don't tell me nothing about a, then I cannot find f of a, right? Okay, what happens if you do this right here? Can somebody tell me? Just a little assumption. If we do this, what happens? If you put this slight change over there, what happens now?
Nothing.
Nothing happens?
I don't think it changed anything. Because it's
Don't
either,
you have to do it backwards?
Now,
No,
you see, now, if I do this now, if I add the inequality here, now if I ask you f of -2, you see now, if I ask you f of negative, what you gonna do now? You have right to use
it's
both
not-
of them.
I think when we do that, it's not the function.
Exactly.
Because
Yeah, exactly. Thank you, Sherif.
for
You
x,
see, when we change this here, now if somebody asks me what is f of -2, the change I did gives me the permission of using both of them, right? If I use the first one, it's going to be 5. If I use the second one, it's going to be 17, right? Since I have two different answers, then it is no more a function, you see? Okay, that is what's going to happen if you do that change, okay? But we don't do it unless we did a mistake, okay? All right, so this is how to evaluate some functions, right? How to evaluate some functions. Evaluating a function is a substitution thing, right? It is a substitution thing, all right? So, of course, we can make the function a little bit more complicated stuff, but we are just doing 163. We don't try to do a lot of stuff, that are really, out of range for us. So right here, so how to find the x-intercept? Finding x-intercept and y-intercept for a function. Remember, we said for any graph, for any equation, if you want to find the x-intercept, you have to do what? Can somebody remind me?
Set y equal to 0.
Set y equal to 0 and solve for x. Thank you very much. If you want to find the y-intercept, what you do? You do the other way around, right? Exactly. So we're going to apply the same thing for the function. We're going to apply exactly, if my function is y equal f of x, this is my function, right? If you want to find the x-intercept, we set y equals 0 and we solve the equation. The equation f of x equals 0, right? If that equation is easy, we have an easy job to do. If that equation is not easy, we have a harder job to do, right? To find the x-intercept, we solve the equation where f of x equals 0, right? And the x-intercept as the solutions. The solutions are the x-intercept. Okay? Now, what is y-intercept? Can somebody tell me what is y-intercept?
F of 0.
F of 0, thank you, Sherif. Look, the y-intercept again, in general, not talking about a function. The y-intercept is when you set what variable to 0? When you set x to 0, right? When you set x to 0, what you get? You get f of 0, right? Okay, the y-intercept is always y equal f of 0. The y-intercept is always f of 0 or 0 comma f of 0, right? That's always y-intercept, okay, if it exists, okay? So y-intercept for a function is the image of 0. The x-intercept, you have to solve something, right? But for the y-intercept, is just the image of 0, okay? So let's give examples like that real quick. If you say f of x equal to f of x equal to x squared plus 2x minus 3, right? So find, you see, which one is easier to find? The x-intercept or the y-intercept? Which one is faster to find?
X-intercept.
The
X-intercept.
You think so?
The y-intercept's easier. It's right there.
Because y-intercept is just f of what? F of whom? So y-intercept is f of?
-3.
No, right here, it's -3, is f of 0, right? Thank you. The y-intercept is just f of 0. So the y-intercept, you don't solve nothing. Actually, you just plug in 0, right? So the y-intercept is always easier. In the context of a function, the y-intercept is always easier to find, right? Because you just plug in 0, okay? Everybody, the y-intercept is easier because it is just f of 0. The y-intercept is f of 0, which is -3. So the y-intercept is 0, -3. For the x-intercept now, you have to solve. You see, solve x squared plus 2x minus 3 equals 0, and now you solve it, okay? If it is an easy, this one is not hard to solve, so you can go ahead and get the solutions real quick, right? So, but if it was harder, then you have to spend some time, right? So what are the solutions here? What you do? So what method you go with?
Right?
We can charge do what? Go ahead, tell me what you did, Sharif. Well, so what method we're going to apply here to solve this one? We can factor out. Thank you. This is x plus 3, x minus 1, right? Equals 0. So we get x equal -3, or we get x equal 1. So the x-intercept are -3, 0, and 1, 0, right? Okay. So to find the x-intercept and to find the y-intercept, you just go ahead and do so. If you have f of x, I give you this one. F of x equal to absolute value of x minus 5. Find y-intercept and find x-intercept. Go ahead, everybody. All right. What is the y-intercept here, which is always easier to calculate, right? What number we plug in to get the y-intercept?
0.
We plug in 0, right? To get the y-intercept, we just go ahead and we plug in 0. So how much we get then when you plug in 0?
I got -5.
You got -5, and you are correct. F of 0 is absolute value of 0 minus 5, which is -5, right? So y-intercept is 0, -5. And the x-intercept, what we do to get the intercept? We solve what equation? Absolute value of x minus 5 equals 0, right? What are the solutions here? Do you remember what you do?
I got 5 and 5. That's it. That's the only intercept I got.
You got only -5,
No, I got +5.
+5 only. So look, what we used to do when you have an absolute value equation, we try to get the absolute value by itself, right? By adding 5 on both sides. So we get absolute value of x is equal to +5. Now, when you break it down, do you remember how many equations we get? We get 2, right? We get x equal 5 or x equal -5, right? So we have 2 solutions. So you get 5, 0 or -5, 0. So these are the x-intercept and the y-intercept, right? Okay, so now what can we do now? We're going to try to learn how to find the domain and the range from a function, right? From a graph. We're trying to learn that. How to find the domain and the range from a graph. Okay? Basically, how to get information from the graph. Getting information, getting the domain, right? And range from a graph. Okay, so let me see if I can go to the, to Alex and see, for instance, the textbook, get the textbook out. Okay, so we can read some graphs. That is textbook right here. Okay, so this is 2.2, right? There's 2.3 right here, okay. Okay, all right. So right here, at first we're gonna try to read, if you have a graph, what is f of this, what is f of this? Let's focus on this graph right here. Everybody see very well? Okay. First of all, this graph, does it represent a function or not?
Yes.
It does, right? So let me get it here. So this graph does represent a function. Okay. So when I say this, how to read, for instance, when somebody asks me how to read h of 3, how to read that? What do you think?
H of 3 is 3.
Everybody sees why h of 3 is 3?
Look at the x coordinate on the graph. The
Uh-huh.
3 meets up with the 3 on the y. On the
Exactly.
y-axis.
Thank you. You see, this 3 is an x value, right? So basically, I have my point. I have 3. I'm asking what is the y value associated to 3, right? I know the x value. I'm asking about the y value. The y value is missing. So that is a 3 here. This is a 3 right here. We go here. So, and we have to go until we meet the graph somewhere, right? And how many times we can meet the graph? How many maximum? Only what?
Once.
Only once, right? Why we cannot meet the graph like twice or 3 times? Why? When you go vertically, why?
Because then it wouldn't be a function.
Exactly, because of the vertical line test. Thank you. When you miss the graph only 1 time, and then you go this to read the y. You see, this is f of 3 right here. Okay. How much is f of 2? What do you think? How much is f of 2? F of 2 is, can somebody give me the answer?
4.
F of 2 is 4, right? Because you go this, and you go this, is 4, right? How much is f of 4 now?
Zero.
Everybody sees this 0? Because what are the x-intercept here from the graph? We have 2 x-intercept, right? Which is this one, and which is this one, right? So 4 is an x-intercept. So f of 4 is a 0, right? Because we have the point 4, 0, okay? Etc., etc. So this is one way to ask. So now if I ask you now, find x such that f of x is equal to 2. You see? You see, right now here, I flip the question over. Now, I'm not asking for the y now. I'm asking for the x, right? So that 2 here is a y value, right? That 2 here, this 2 is a y value, right? It is this 2 right here, you see? I'm asking here, what are the x's that are associated with 2? You see, I don't know the x. I don't know the x. What are they? You see? It can be 1, it can be 2, it can be 3, it can be 4, right? I don't know how many yet. Okay? What should do, you think? Somebody, to read those x's, what should we do?
The line, the horizontal line.
Exactly. Now, you know, when we read the y value now, when we read the y value here, which is 2, what you draw? Now we draw a horizontal line, you see? We draw a horizontal line through 2. And every time we meet the graph, we have an x value, you see? That is the first x, and that is the second x, you see? So the first x, unfortunately here, they are not exact numbers, but the first one is about 0.6, right? Or 0.5. And the second one is about 3.6 or 3.5, right? So what are the values of x such that f of x is 2, we have 2 values, right? Okay, if you are given x and you want to read y, you go vertically, right? If you are given y and you have to read X, you go horizontally, right? Everybody agree with that? Okay, so now, after we're done with that now, we're gonna try to read the domain and try to read the range. Okay? How to use the domain and how to use the range. So I have to find an easy example first. Right, okay, so. All right, to find the domain is the set of x's, right? To find the range is the set of the y values, okay? So now look at this one right here. Let's concentrate on this one. So let me go here. How to use the domain, how to use the range. All right. So look, the domain here is the set of x values, you see, on the x-axis that are covered by the graph. Okay, that is a domain. What part of the x-axis that is covered by the graph, above or below? Okay, that interval is a domain. Okay, the range here is all the way around. The range is what part of the y-axis, right, that is covered by the graph. Look, for instance, here, this function as it is, as you see the graph right here. If I ask you f of -4, can you find f of -4? Can we find f of -4?
No.
Everybody see? Everybody that got the answer? You know, I'm talking with only a couple of people. You know, I hope everybody to participate, frankly, you know.
Sure.
I know, you know, I don't know if you can, if you are in a setting where you cannot talk, but you know, the whole class, you know, I'm talking, that is not good, you know. If you don't understand, you have to say you don't understand. So I want everybody like to, but so when I say what is f of -4, I hope like, you know, we get like more answers. That's only like only two people that talking to me. F of -4, we cannot read it, right? You know why? Why, for instance, we cannot read it? Because what you see here, what do we see here?
There
We
are no
see-
points spotted around -4.
Exactly. There is no graph or negative, and here we see a limitation. My graph stops right here. My graph does not go any further than here, right? Every time you see this, or you see this, it means your graph stopped right there, right? It doesn't go any further. When you see this, what you mean? What it does mean?
It continues.
Yeah, it goes forever, right? Goes on. You see, whether you see this or you see this, right? Even if you don't see no arrow, and you see just a line that has no circle around it, right? No dot around it, it means that graph goes forever. You see, since my graph stops right here, it means I cannot read f of anybody beyond -3. You see, if you ask me what is f of -3.1, I cannot read it. F of -4, I cannot read it. F of -5, I cannot read it, right? So what is the last
Why?
element? What is the first element in the domain then? It's gonna be this one, right? You see, the domain will be here all the way. Everybody here is covered by the graph, right? Until, do I have any end to that? Do I have any end to what you know, how much I can go to the right?
No.
There is no end because this stuff keeps on going. So for instance, can we read f of 7 here? Would we be able to read f of 7?
Yes.
Yes.
Of course, even if I don't see it, if I keep going, If this one keeps going, I could read f of 7, right? So what is the domain then? What is the graph start where from the left? The graph start at what number?
-3.
-3, right? The graph start at -3. Where the graph ends?
Has no end.
Nowhere, is infinity, right? Okay, now we have to decide, do we include -3 or not? Remember what we said, like last week?
No.
We don't include -3, so what we put then? A parentheses, right? -3 is not part of the domain because this is an open circle, right? So -3 is not part of the domain. Open circle, so we have this, right? And of course, infinity, we always put parentheses, right? So that is a domain. You see, the domain here is any piece of the x-axis that is covered by the graph. That is a domain. Now for the range, what axis we focus on for the range? We focus on the y-axis, right? The domain is the x-axis. So now we have to do the same, but now we have to focus on the y-axis, right? For instance, what do you think? Is -3 part of the range?
No.
You see, any y value that is not associated to no x value is not part of the range. The range is the set of the y values, right? The domain is a set of x values that are associated with y values. The range is the set of y values that are associated with x values, right? If an x value has no y, that x is not in the domain. If a y value has no x, that y is not in the range, right? So what is the first number that's going to be in the range? What that number is, you think?
2?
It's -2, right? It's here, right?
Yeah.
You see, we go from here, everybody here is in the range because all these values are covered by the graph. And then we have no end to it because this stuff just keeps going, right? So now -2, is it part of the range or not? The -2, is it part of the range or not?
No.
No.
It is not, right? So we have put this, right? So the range is the interval -2, infinity, right? So if you happen to have these problems, in a test, there is no calculation. There is no calculation whatsoever, right? So for instance, if you go here, okay, right here, this one. What do you think? What is the domain, everybody? Don't get distracted by the grid. You see, the grid goes only from -5 to 5 for the x and y. Don't be distracted with that. What is the domain, you think? Think about it. Think the domain and the range. Everybody think about it and write your own answer before we go over it. Everybody write your own answer for yourself before we go over it. All right. So what do you think? What is the domain? From what x to what x? Say again, go ahead.
-infinity to infinity.
Thank you very much. You see, even if this one, you see, for instance, somebody who missed the class or something like that, what is the likely answer somebody would tell me if they missed the class? They would say
0 to 4.
Probably somewhere between -1 and -5.
-1 and +5, right? You see, if somebody missed the class today and they have a vague idea of what is the domain, they would say -1 to 5, right? Because this is what is covered by my graph. But the arrows tell me otherwise. The arrow tell me I have no end left side, I have no end right side. So the domain is -∞, infinity. Okay, everybody understand that? You see, because these two arrows, they just keep going. They never stop, right? Okay, what is the range now? From what y to what y? Bottom to top.
And -∞ to 4.
-∞ to +4, right? The bottom has no end because the arrows keep going. So it's going to be -∞, but the top has an end. It's 4, right? So is 4 included or not?
Yes.
4 is included, right? So,
Yep.
so that is, you see, again, these kind of problems, they don't have calculations. If I understand them, it's going to help me a lot because they don't have calculations, you see. So here's the domain here is, of course, the domain here is all the way -∞ to +∞. That is the domain, right? And the range here is all the way from -∞ all the way to +4, and that is closed, right? Now, if I do a slight change here, look, everybody, if I do a slight change, and then we're going to stop here for today. If I do this, now, what is the domain now? And what is the range now?
Domain is -1 to 5.
Okay, how are you going to write them out? How are you going to write? You said -1, this is an interval, right? -1, 5, right? What you put before -1, a parenthesis or a bracket?
Bracket.
A bracket. What you put after 5, a parenthesis or a bracket?
Parentheses.
Parentheses, right? You see now, thank you very much, because now, because of this stuff and this open circle, now my domain is only here. That's it, right? And this is closed and this is open, right? Okay, you can write your name, everybody, for the attendance. I forgot to say that. How about the range now? If I do this change, how about the range? From what y to what y? Bottom to top.
-5.
-5 to the bottom and then to 4, right?
Yes.
Okay, do you decide to include -5 or not to include -5?
Huh?
Do you decide to include -5 or not to include it, to put a parenthesis or a bracket?
Oh, I'd include it.
Yes, because even if it was supposed to be excluded here, because we have an open circle, but at the same time, we have a closed circle here. So we have to include it, right? And then the 4 is included, okay? All right, so when you come back, you have to write your name, to be counted present. When you come back, we're gonna continue on the functions. We're gonna try to find the domain with the calculations, right? Not only with the graph. And, again, this is a section, maybe it has some elements that you haven't seen in O83. So the attendance is very important, right? Okay. Do you have any questions for today?
Sir, I have always a problem with that. When I write my name, I can send it.
Ah, okay. So I'm sorry about that. Okay. I'm going to mark your name. Thank you. Yeah. All right, everybody. See you Thursday. Thank you very much.
Okay, thank you.
Thanks.
Bye, Professor.
Bye.
Bye.
Thank you.
Said we have an
Bye.
exam this Thursday, right? I mean, the 25th, right?
The first test?
Yeah, the actual, an actual exam.
No, it's not. I don't think it's the 25th.
Oh, okay.
I think it's like the 5th, October 5th.
Oh, okay. Do we have any quizzes coming up again?
No, the first time you're gonna have you're gonna have something, it's gonna be the exam number, the test number 1. It's gonna be
Oh.
on Zoom. So I will put a review sheet on Brightspace, right? I will
Okay.
put a review sheet on Brightspace, and then, we're gonna do this, okay?
Okay.
All right.
And you'll give us like notification ahead of time of when it is, right?
Say again?
And you'll give us like a heads up of when it is, right?
Yeah. You see, the calendar is right there. Unless something happens, I think we're gonna go ahead and do the test exactly on the date of the syllabus, and then a week. I think 1 week away from that, I will put a review sheet on Brightspace. Yeah,
Okay, thank you so much.
you're welcome. All right, thank you.
Have a great weekend.
Thank you.